Good morning, students. We ended last week with the design process that is realization and evaluation of product. Today's lesson is about the smart materials. We have seen in previous lessons the traditional materials we use for design. Uh, we have gone through some materials which are going to make a recap. So we have seen about wood, right, and their uses. You can follow in your book also. We have also seen materials, metallic materials, which are used in various design. For example, cars, kitchen utensils, openings, and buildings also made in metals, different types of metals. Other types of materials, they are glass. So glass is a very used material, used for to make bottles, window panes, to make kitchen utensils, also plates and various objects also made from glass. We have also seen concrete, which is made up of cement, rocks, sand, and water, which make concrete a very useful material, which can be casted to make buildings, to make blocks, to make benches, garden benches, and to make houses. Okay, so another type of material, traditional material we have is plastic, which is a synthetic material made from petroleum products, which is very used in our everyday life. So plastic uh, is used for can be recycled also. It is used for many, there are many uses of plastic, and these materials we have seen are called traditional materials. Okay, so today we are going to go through another type of material which is called smart materials. So these are different from the traditional material because they react under certain conditions. Hein. Donc, pour dire ça en français, donc les smart materials, donc ils réagissent à certaines conditions, par exemple à l'électricité, à la chaleur, euh, avec de la friction, donc ça réagit. Donc dans votre livre, il y a une définition. Smart materials are materials which react and change their properties in response to an input. Un input, ça veut dire que une action qui entraîne une réaction. Donc, the input may be electricity, sunlight, temperature ou pressure. Donc ça veut dire que si je passe de l'électricité à travers le matériau en question, ben, ça va changer de forme, ou alors de couleur, ou alors ça va réagir, ça va bouger peut-être. Euh, Certains matériaux réagissent au soleil, hein, à la température, moins de température, c'est ce qu'on va voir dans cette leçon-là. Donc, euh, un de ces smart materials, nous avons ce qu'on appelle les phosphorescent pigments, hein, des pigments phosphorescents. Donc, phosphorescent, ça veut dire que ça a un rapport avec la lumière. Okay? Donc, phosphorescent pigment is a type of pigment which absorbs light energy from light source and releases light energy in the dark. Ça veut dire que pendant la journée, le matériau en question va absorber la lumière, ok? Et quand la lumière baisse, ben, il va relâcher cette lumière-là, donc il va briller. Donc, ce qu'on appelle des matériaux qui brillent dans le noir, ok? On appelle ça des glow in the dark material. So, this is an example of phosphorescent pigment, ok? Donc, c'est du phosphore généralement. So, they are used in clocks. Hein, donc, les lettres des pendules souvent sont faites en phosphorescent material. So, watch hands, les montres. Donc, on peut même lier l'heure dans le noir. Glow in the dark objects and fire exit sign. Par exemple, dans les cinémas, par exemple, nous avons les fire exit sign. Ça ne marche pas à l'électricité. C'est juste une peinture phosphorescente qui permet de briller dans le noir. Donc même dans le noir, quand il n'y a pas d'électricité, ben, the exit sign is still visible. Okay, so these are some examples of the uses of phosphorescent pigments. Okay, what I said, watch, glow in the dark objects, ceux qui ont vécu. Par exemple, là, pour les fêtes, vous allez voir sur beaucoup par exemple, ces sticks, hein, glow in the dark sticks, okay, with different colors, uh, for stickers which we can glue on the ceiling to make decorations, the clocks, the watch, okay, the signs, the safety signs which glue in the dark, okay, the exit sign, the toilet, whatever. So on the roads, in planes, you can have these uh, stickers on the floor, okay. So these are phosphorescent pigments. It is said to be a smart material because, as I said, it reacts with sunlight or in the absence of light. Another type of smart material, we have photochromic materials. Alors, photochromic, photo. Alors, when we say photo, it's a Latin word which means light. It deals with light. Okay. Alors, donc, photochromic material. Donc, photochromic material changes color when exposed to light. Donc, quand on expose au soleil, ben, ça change de couleur. Ok, donc it changes from transparent to opaque when exposed to sunlight. Donc, ça peut passer d'une couleur opaque, ou alors ça peut passer d'une couleur transparente. Donc, the uses, you can use it in photochromic lenses, for example, glasses. They can use photochromic lenses. So when there is rain or when there's low sunlight, the glass is clear and transparent. When there is an amount of sunlight, okay, it darkens to make the lens proper for seeing in the bright light. Okay, so it darkens in sunlight. Okay, the more there is light, the more it is dark. So it is a photochromic lens. Okay, uh, you can also use photochromic glass, for example, for window panes. Okay, when there is low sunlight, it is clear. When there is too much sunlight, it darkens to make the environment more proper to live in. So you can use it also in what we say nail polish. Okay, so there are photochromic pigments in the polish. So indoor, when it is inside, it is a one color. When you go outside with much sunlight, it changes color. It depends on what color we want. So there are nail polish which are photochromic nail polish. For example, indoor, here have nail polish. Indoor, it is of a very pale color, and we come outdoor, it becomes very colorful. Okay, so this is one example of the use of photochromic material. So you can use it on inks for printing t-shirt, for example. In indoor, you can have a t-shirt which is black and white, have an indoor t-shirt, indoor color. When you go outside, but it changes color due to the light you have, the sunlight, so it reacts with the sunlight. Okay, so these are some examples of photochromic material. The photochromic materials are one more example of smart materials. So you have also, as smart material, thermochromic inks. Okay, the thermochromic materials. The the term thermo means deals with temperature. Okay, so thermochromic inks are inks that reacts due to temperature. For example, the properties of ink, thermochromic ink changes color when exposed to temperature. Okay, so the uses used on decorative objects such as mugs. Here in Mauritius we call it magic mugs, which changes color when we pour a hot liquid or a cold liquid in it. as a warning sign to show increase of in temperature. For example, in buildings, in some high buildings, we have uh, paints with thermochromic painted with thermochromic paints. So when it becomes of a certain color, that means that temperature have rises or decreased. So these are safety signs using thermochromic paints. Okay, for example, the coffee cups, when we add hot coffee in it, it changes color. Okay, here's an example, is a video showing the the when pouring hot water in the mug is black. So how do you know that the liquid inside is hot? So you pour hot liquid. So there is a picture that appears on the mug due to the heat. It can be also a safety element. Okay, to know if the liquid inside is hot or cold before you drink it. So this is used for baby spoons. So the baby spoons are made of plastics. So when it is uh, used for feeding the babies, so if the food is hot, it will change color. Okay. For example, in cells. So the cell, you can know how much electricity remains in the cell by the amount of heat it generates when in use. For example, there is a sticker here which indicates the amount of power it contains. The some cans, for example, if it is fully chilled, if it is cold, there's cold drink in it, there is a drawing which will appear on the can. If it is at room temperature, the drawing is not visible. Okay, it can also be used as a thermometer. There are thermochromic stickers which can be used as thermometers, uh, where mercury and alcohol cannot be used. Okay, um, in some cases we have also uh, thermochromic inks used on t-shirts. For example, funny t-shirts that change temperature when we touch it. So the temperature of the body of the hand, for example, changes the color of the linen of the clothes. So these are some examples, some uses, some applications of thermochromic material, thermochromic inks. Okay, so thermochromic ink are also in the category of smart materials. So another smart material we have is the polymorph materials. So polymorph, when we say poly means many. Okay, many, and morph means shape. Okay, so these are materials which can take many shapes, which can be shaped very easily. Um, for example, the properties: polymorph is a thermoplastic which can be shaped and reshaped. So, ce sont des plastiques qu'on appelle des thermoplastiques qu'on peut, euh, comment ça s'appelle, chauffer, le faire prendre n'importe quelle forme qu'on veut. Quand ça refroidit, ça reste dur. Donc, on peut le rechauffer, le rechanger de forme. Donc, c'est polymorphe. Donc, polymorph comes in a form of granule, but becomes workable mass when heated to a temperature of 62 degrees or above. Hein? Donc, on peut le chauffer à 62 degrés, qui n'est pas beaucoup au fait. On peut juste comme s'il y avait de l'eau chaude dessus. Donc, ça peut changer de forme. After cooling down, the workpiece becomes a solid mass. Donc, quand ça refroidit, ça devient dur. Donc, polymorph is an expensive material. Alors, the uses of polymorph is commonly used for 3D modeling. Par exemple, pour faire des objets des objets en 3D, pour faire des maquettes. Donc on peut utiliser des plastiques polymorphes. Donc ça, ce sont l'exemple de plastique quand c'est at room temperature. Par exemple, ce sont des granules ici, ça sont appelés des granules. Et ça, ce sont des powder, plastic powder. So when it is heated, it becomes a paste. It can be shaped, can be casted, okay? And when it dries, when it cools down, it remains solid. Donc, for example, it can be the plastic has been heated, so it becomes a paste. It can be worked out and make models with it. Okay, you can mix whatever you want. So when it dries, when it cools down, it remains so rigid. Okay, so this is an example of how plastic polymorphs are used. Okay, so these are the original state of the plastic. It comes in granules. Okay, you buy it in granules, in pellets, pellet form. Okay, this is a raw material. So this material will be heated. Okay, we can only use hot water. So we pour it into a bowl and we add hot water in it. So when it is heated, it melts and it becomes a paste. Okay, which can be used when it softens. So it can be used and shaped to make whatever we want. It's like a bit like uh, plasticine, okay? But we must work it when it is hot. So here you are, it becomes a very malleable material, okay? So you can shape it and make it take whatever shape you want under heat. So when it cools down, okay, when the material cools down, it remains a rigid material. It becomes a rigid material. So here you are. So it becomes a very rigid material. So this material can be remelted again to make other materials. So you can repeat this process again and again. So you put it in water, in hot water again, it becomes malleable again. So this is what we call uh, polymorph materials. Okay, so here you are. So we will end this term with this small lesson about smart materials. So you can look around yourself and find some smart materials you have at your place. Thank you. So we will be seeing us together on next year. Till then, stay safe.